Beyond the Hope believes that aviation will be electric and is committed to produce the first practical and certifiable aircraft using electric propulsion powered by hydrogen fuel cells. Hydrogen as a fuel requires a dedicated design because of the volume and weight of the storage. We are in the preliminary design phase of the aircraft. PO1 will be certified under CS25, able to carry 6 to 8 passengers for 800 nautical miles at 310 knots. Its propulsion system has 2 pusher propellers, and the electric power is provided by 2 banks of fuel cells, completely independent from each side. The aircraft will have a metallic structure, except for the control surface that will be made of composites. We have a pressure bulkhead separating the passenger compartment from the fuel cell compartment, so any leakage in the fuel cells will not contaminate the cabin. We have the outflow valves in the forward pressure bulkheads to avoid any leakage in the ground coming to the cabin. We have used an optimized cross-section that has been patented by Beyond the Hope. CFD and theoretical drag and lift calculations had been confirmed by wind tunnel tests done in Netherlands. We made the choice of gaseous hydrogen to take advantage of existing infrastructure for other modes of transportation. Hydrogen storage at high pressure, 700 bars, and all the piping, this high pressure, will be routed outside the aircraft. The tanks are placed at the wing roots and the wing tips, so any high pressure leakage will vent to the outside, avoiding the risk of an explosion or deflagration. All the tanks are mounted over the wing box, so they are protected in the case of a crash landing. All the high pressure hydrogen is stored outside the aircraft, fuel lines and tanks. The pressure is reduced to 14 bars at the wing roots and then routed to the aft fuel cell compartment, where it is naturally vented because it's not pressurized. In the fuel cell compartment, we have 6 fuel cells of 400 kilowatts, producing a total of 2.4 megawatts electrical power that feeds electric motors with 850 volts. So the fuel cell compartment is considered a fire zone with proper monitoring and suppression. We have independent electrical supply for each engine, and we don't use any propulsion battery in the aircraft. And there is, of course, direct conversion from hydrogen to electricity without any combustion. Each nacelle is a complete propulsion module, including compressor for the fuel cells, heat exchangers for the fuel cell cooling system, and the electric motor, turning a constant speed 2.8 meters diameter propeller. The heat exchanger provides adequate cooling for the fuel cells in all flight conditions, and also gives some trusted cruise conditions. The aircraft will be a full fly-by-wire aircraft using electric actuators. The aircraft will not have a hydraulic system. Landing gear retraction will also be electric, and brakes will be electric as well. So this is done to reduce maintenance costs. The control surface will be split for redundancy. The fly-by-wire system will have a battery for emergency conditions in case of a double engine failure. The cabin has been designed for 6 to 8 passengers, 6 in club seating, 8 forward facing, with space in the front for a baggage compartment and a galley. There is a full-time toilet in the back. The cockpit is using state-of-the-art avionics. We have a wide door, 85 centimeters wide, that allows the loading of a stretcher without tilting the patient. Passenger cabin is fully segregated from the hydrogen compartment by the pressure bulkhead, without any possibility of hydrogen being leaked to the cabin. Hydrogen safety is ensured by a layered approach, by segregation, detection, and ventilation. There is no possibility of hydrogen accumulation in any part of the airframe due to natural ventilation. In case of any leakage in the lines, low pressure valves will isolate the system. Young the Whole has a full-scale test bench for fuel cells here in Toulouse. Fuel tanks development has included burst tests. Wind tunnel tests have been carried out in Netherlands to validate the CFD models. EASA DOA is in the phase 2. We have a pre-application contract with EASA for establishing the certification basis. We are going to have a type certification for the engine itself as well. The airplane is in the preliminary design stage. All the systems and structures have been sized in accordance with CS25. We have been able to integrate hydrogen electric propulsion in a way to meet CS25 requirements. We will be delivering the first certifiable practical electric aircraft.